So this is the answer key to the review. So number 1, a ball is attached to a spring which is stretched and then let go. The height of the ball is given by the sinusoidal equation y equals negative 3.5 cosine of 4 pi over 5t plus 5, where y is the height above the ground in feet and t is the number of seconds since the ball was released. Part A, at what height was the ball released at? Part B says what is the maximum height the ball reaches? Both of these are talking about heights. So these are both dealing with the y's. The y is the height above the ground. We can see in part D that we are going to be graphing in a little bit. And graphing, we said we're always going to follow the 4 steps of f pi. So part A and B, if they're talking about the y's, it means they are dealing with the a step of f pi. So the a is negative 3.5, and we're going to multiply cosine's critical points by negative 3.5. So cosine's critical points are 1, 0, negative 1, 0, 1. Multiply them all by negative 3.5. You get negative 3.50, positive 3.50, negative 3.5. But then this one also has a vertical shift of plus 5. So we are going to add 5 to all of these. So negative 3.5 plus 5, we get 1.5. 0 plus 5, we get 5. 3.5 plus 5, we get 8.5, and so on. So what height was the ball released at? That would be the first height that is here, 1.5 feet. Part B, what is the maximum height the ball reaches? We're looking at this list of numbers that we have right here. The maximum is 8.5 feet. Part C, how many seconds does it take the ball to return to its original position? So it starts at 1.5 and it ends at 1.5. So that is 1 full cycle, which remember is the definition of period. So part C is asking you to find the period of the equation. Period, remember, from an equation, we have the formula 2 pi divided by the frequency. The frequency is what is in front of the x, or t in this case, so 4 pi over 5. You can plug this into your calculator. I would put the 4/5 in parentheses when I go to do it, so 2 divided by 4/5 in parentheses, and you should get 2.5 seconds. Part D, draw a rough sketch of one complete period of this curve below. Label the maximum and minimum points. So my x or t's in this case and my y's, we already have the y's from part A. T or x, we always start at 0. So now to figure out what we are going to count by, that is the I part of f pi. We already knew the f, the frequency, was 4 pi over 5. The p for f pi we found in part C is 2.5. And I, remember, is your period divided by 4. So 2.5 divided by 4, and you should get 0.625 or 5/8. So that is what we are going to count by in our table. So 0.625 plus another 0.625, we should get 1.25, plus another 0.625, we should get 1.875, plus another 0.625, we should get 2.5, which again, remember, you should always end at your period. So I'm going to label all of this. Make some room here. Label all of this on my axes. I'm going to count by ones. Remember, if you count by ones, you do not have to label. So now plotting the point at 0, we are at 1.5. At 0.625, we are at 5. At 1.25, we are at 8.5. At 1.875, we are back at 5. And at 2.5, we are back at 1.5. Remember, no straight lines, curves only. So there is my curve. They want you to label the minimum and the maximum points. So down here we have our minimum at 0, 1.5. We have another minimum over on the right at 2.5, 1.5. And we have a maximum up at top at 1.25, 8.5. Part E, what is the average rate of change of the ball to the nearest hundredth on the interval from 0.5 to 1? Average rate of change, remember, means slope. We want to do the change in y's over the change in x. And this interval here, these are your x's, or t's in this case. So we want to plug them in. So I am going to plug in a 0.5 for t. Then I am going to plug in a 1 for t. And to get these values, I'm just going to go straight to my calculator. Make sure that if you go to mode, make sure you are in radian mode, that you have a box around radian. So we have negative 3.5 cosine of 4 pi divided by 5 times 0.5 plus 5. So there's the y when x is 0.5. And then we'll type in the same thing, but make it a 1 that we are plugging in. And we get a y of 7.83, yada, yada. Now, do not round yet. Remember, no rounding until you are done with the problem. So here were our answers from the calculator. I'm going to make it smaller so I keep working. So now my slope formula, change in y's, I am going to subtract them. over the change in x. You can type that into your calculator and then round to the nearest hundredth to decimal places, and you should get 7.83. Question 2. A sine function increasing through the origin can be used to model light waves. So here's my x and y axis. Here is my sine function. It is increasing through the origin. So notice as I come out of the origin, it is going up. That's just your regular sine function, nothing special about that. It then says violet light has a wavelength of 400 nanometers. So we're starting at 0. And our wavelength, we are ending at 400. Over which interval is the height of the wave decreasing only? So splitting this up, if this whole thing is 400, my halfway point should be 200. And then we do break those into halves as well. So from 0 to 200, that halfway point would then be 100. And between 200 and 400, we should be at 300. So over which interval is the height of the wave decreasing? So we're going up, 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 up. We hit the spot up at the top here, this maximum. And then my graph starts going down. I'm decreasing, decreasing until I get to the 300. And then it starts going up again. So we are decreasing from 100 to 300. So answer choice 2. Question 3. On the axes below, sketch at least one cycle of a sine curve with an amplitude of 2, a midline at y equals -3/2, and a period of 2 pi. Well, if you're graphing, we said that the 4 steps we're going to follow are always half pi. A is amplitude. They're telling us that there is an amplitude of 2. We always multiply our critical points by 2. They said that this was a sine curve, so the critical points for sine, 0, 1, 0, -1, 0. So multiplying, we get 0, 2, 0, -2, 0. Now, then we usually look at the equation to see if there is a vertical shift. This one says that there is a midline, but remember your midline is equal to your vertical shift. They mean the same thing. So that means that my vertical shift is -3/2. So I am going to add or subtract -3/2 to all of these numbers. So 0 plus -3/2 or 0 minus 3/2 is -3/2 or -1.5. 2 minus 3/2 is 0.5. 0 minus 3/2 is -1.5 again. -2 minus 3/2, -3.5. And 0 minus 3/2, -1.5. These are my y's. So if you're going to make a table, our y's, -1.5, 0.5, -1.5, -3.5, and -1.5. To get the x's, this is the part of FPI, half pi. Now, F is frequency. I don't have the frequency right now. However, the frequency, remember, just helps us get the period because the period is normally 2 pi divided by the frequency. However, they went into straight up just giving us the period right from the beginning. We already know that this period comes out to 2 pi. So we don't even have to worry about the frequency here because, again, that step is just to help you get the period. But we were already given the period, so the frequency does not mean anything to us right now. I is our period divided by 4. So 2 pi divided by 4 is pi over 2, or 1 pi over 2. That is what we're going to count by in the x's. Always start with 0. And then we have 1 pi over 2. Then 2 pi over 2. Then 3 pi over 2. And last would be 4 pi over 2. So you should have room if you want to skip every other line. Just to keep the graph a little spaced out. Plotting the points then, 0, negative 1.5. 1 pi over 2 is at 0.5. 2 pi over 2 is at negative 1.5. 3 pi over 2 is negative 3.5. And 4 pi over 2 is negative 1.5. Connect with a curve. Remember, no straight lines. And there is your graph. Part B, explain any differences between a sketch of y equals 2 sine of x minus pi over 3 minus 3 halves and the sketch from part A. We're going down the line here. 2 is your amplitude. Same amplitude we had in part A, so that's the same. My frequency is 1 here. Remember, if you don't see something in front of the x, there is a 1. That's where your frequency is located. Frequency we didn't have in the first one, but if I find the period right now, 2 pi divided by the frequency, 2 pi divided by 1, I get the same period that I had for the first one. So that's the same. I also see here my vertical shift is negative 3 halves. Vertical shift, remember, is equal to the midline, so that's the same as part A. So the only thing that's different here is this negative pi over 3. This we don't graph ever, but we do have to recognize that this means that we are shifting pi over 3 to the right. Remember, horizontal shifts go left and right, opposite the sign. So a minus pi over 3 is going to go towards the positive side of the x-axis, so that's to the right. So it's going to the right pi over 3. Question 4. Determine the amplitude, period, frequency, and vertical shift of the following cosine function. All right, amplitude, remember, is the height from the midline. We have to know our definitions for this. So my midline, if I draw it in, my midline is at y equals negative 3. So my height from the midline, it goes up 2 boxes. So my amplitude is 2. Now continuing with definitions. Period is how long it takes to complete one full cycle. So right here, this is my one full cycle of cosine. Cosine, remember, starts and stops in the same place. So this is cosine. And hopefully your graph is a little bit more clear than mine, but that ended at pi. So my period is pi. Frequency. There are 2 ways we can find frequency right now. Frequency is how many cycles are in a length of 2 pi. So we had 1 cycle to pi, and then we had a second cycle, got us to the 2 pi. So my frequency would be 2. Or you could have done the formula for frequency, 2 pi divided by the period. I'll make that a little clearer that that's a p. So 2 pi divided by the pi that we found also gets us the 2. So either way, frequency is 2. And last, the vertical shift. Remember, vertical shift is equal to your midline. So I'm down at -3. So there is my vertical shift. Question 5. Sketch one cycle of a cosine function that has an amplitude of 3, a midline at y equals 1, a period of 2 pi over 3, and that passes through the point 0, 4. So this is just like question 3a. Very similar. So sketching, remember, we're always going to follow half pi. A is 3. This is cosine. Cosine's critical points are all going to get multiplied by 3. Our midline or our vertical shift is at 1. So adding 1 to all of these. Oops. Here are our y's. Next, to come up with the x's, that's the FPI of half pi. Frequency I don't have, but again, remember, it just helps you get the period, and period was given to us. 2 pi divided by 3. So I don't need the frequency here since I can just go and jump straight to my period. And then I, period, divided by 4. We're going to do 2 pi divided by 3 divided by 4. You can plug that into the calculator. 2/3 divided by 4. Math, enter, enter. You get 1/6. And then we throw the pi in our answer that we did not type into the calculator. So my first x is 0, but then we're going to count by 1 pi over 6. So then another 1 pi over 6 gets us 2 pi over 6. Then 3 pi over 6. Then 4 pi over 6. So graphing this, just a little sketch. Make sure that your x and y axis are labeled. If you're counting by ones like I am on my y-axis, it does not have to be labeled, but if you want to, you can. And then we're going to plot the points. So we have the point 0, 4, which they said it passes through that point, so that just naturally came up by doing AFPI. You didn't have to do anything special with that. 1 pi over 6 is at 1. 2 pi over 6 is at -2. 3 pi over 6 is at 1. And then 4 pi over 6 is at 4. And then connect with a curve, and there is your cosine graph. Question 6. The graph of which function has an amplitude of 2 and a period of 4 pi? So looking at each of these, the number in front, remember that is your amplitude. So we want an amplitude of 2, so that eliminates answer choices 3 and 4. Next, the number in front of the x, remember, is your frequency. They're giving us a period of 4 pi. But if you remember, frequency is equal to 2 pi divided by the period. So 2 pi divided by 4 pi means that my frequency is 1/2. So answer choice 1. Question 7. Relative to the graph of y equals 3 sine x, what is the shift of the graph of y equals 3 sine x plus pi over 3? So this number in here, remember, is your horizontal shift. It moves you left or right, and it always goes opposite the sign. So the positive is actually going to go towards the left, pi over 3. So answer choice 2. Question 8. Graph one complete cycle of y equals -3 cosine of 4x plus 2. So this is just asking you to do AFPI and graph. So A, -3, multiply cosine's critical points by -3. Then apply your vertical shift, which is to add 2 to everything. So you get -1, 2, 5, 2, -1. These are your y's if you're going to make a table. To get the x's, remember this is the FPI of AFPI. Frequency is 4. Your period, 2 pi divided by frequency. We have 2 pi divided by 4, which is pi over 2 or 1 pi over 2. And then I, AFPI, is the period divided by 4. So 1 pi over 2 divided by 4. My I is 1 pi over 8. Your first x is always 0, and then we're going to count by this 1 pi over 8, plus another 1 pi over 8 gets me 2 pi over 8, plus another 1 pi over 8 gets me 3 pi over 8, plus another, we have 4 pi over 8. So graphing, draw your sketch, label your axes, especially the x-axis. And then we're going to plot our points. So at 0, we're down at -1. 1 pi over 8, we're at 2. 2 pi over 8, we're up at 5. 3 pi over 8, we're at 2. And 4 pi over 8, we're back down at -1. Connect with a curve, no straight lines, and there is your graph for question 8. Question 9. The terminal side of theta, an angle in standard position, intersects the unit circle at point P. What is the value of cosecant theta? Unit circle, remember that means that your x is cosine and your y is sine, and that's because they said this was a unit circle. What is the value of cosecant? Cosecant, remember, is the reciprocal of sine. So since sine is -3/7, cosecant is -7/3. Question 10. If theta is an angle in standard position and its terminal side passes through the point -5, 1, find the exact value of secant theta. Now, this one does not say unit circle anywhere, so we cannot use the same concept as the last question, question 9. So as of right now, the only thing we can do is plot this point. So here is my point, -5, 1. If I'm looking for secant, it means I am looking for the reciprocal of cosine. We're going to need a triangle to do this because cosine is adjacent over hypotenuse. So to make the triangle, you're always going to go down straight to the x-axis. So the horizontal side is your x, the -5. The vertical side is your y, the 1. And the angle we're going to use is always the angle closest to the origin. To find the missing side, Pythagorean theorem. The C has to be your hypotenuse, so that is what we're going to look for. Make sure that all these numbers come out positive because they are being squared. So it's 1 plus 25, which is 26. Take the square root. So our hypotenuse is the square root of 26. Your opposite side is the 1. Adjacent side is the -5. And again, hypotenuse is the radical 26. So cosine is -5 over the square root of 26, which means secant is the square root of 26 over -5. And notice we did end up in the second quadrant. So following ASTC, only sine can be positive. So cosine should be negative, which means its reciprocal secant should also be negative. So final answer. So question 11. In which quadrant does theta lie if the following statements are true? Secant of theta is greater than 0 and tangent of theta is less than 0. So looking for the quadrant, we're going to use ASTC. Secant, remember, is the reciprocal of cosine. And if we want to be greater than 0, then it means we want cosine to be positive. A stands for all, so cosine is positive in the first quadrant, so we could possibly be in the first quadrant. S stands for sine, only sine is positive in the first quadrant, so cosine is not, so we can't be in the second quadrant. T stands for tangent. Only tangent is positive there, which means cosine is not, so we can't be in the third quadrant. But the fourth quadrant has a C for cosine. It is positive there, so we could possibly be in the fourth quadrant. Second thing, tangent has to be less than 0, which means it has to be negative. So between the first and fourth quadrant, tangent is negative in the fourth quadrant. It is positive in the first quadrant. So we have to be in quadrant 4. Number 12, find the exact value of tangent of 4 pi over 3 times cosine of pi. So first thing we're going to have to do is convert these angles. They are in radians. We need to get them in degrees. You always want to evaluate in degrees. So we're going to multiply by 180 over pi. The pi's will cancel, and then on your calculator, 4/3 times 180, we get 240. And then pi multiply by 180 over pi, we get 180. So we are going to be looking for tangent of 240 times cosine of 180. Now, tangent of 240, if I go to plug that into my calculator, I get a decimal. This says exact value, which means at some point we are going to our chart. Our chart, though, only has 30, 45, and 60 on it. So that means that we are going to have to do QSFR. Q stands for quadrant. 240 is in the third quadrant. It's between 180 and 270. SF, sign of our function. Our function is tangent in the third quadrant, doing ASTC. Tangent is positive there. And R stands for reference angle. The reference angle for the third quadrant is theta, your angle, minus 180. So this is telling me that tangent of 240 is the same thing as tangent of 60. And tangent of 60, if you look at your chart, is radical 3. We are going to multiply that with cosine of 180. Now, unfortunately, this QSFR does not work because 180 sits on a line. So the first step already, Q, there is no quadrant for the 180. This is where we want to use the unit circle. 180, remember, is over on the left. And that point is the point -1, 0. Cosine, because this is the unit circle, cosine is the x, so cosine of 180 is -1. And then -3 times -1, radical 3 times -1 is negative radical 3. That is your final answer. So let me know if you have any questions on anything. I'd be happy to help. Your quiz will be posted Wednesday morning.